Welcome to the translating word problems with respect to linear systems. This is, I guess, day 5. So today, nothing new. We're just taking everything that we've accumulated in tools, I guess, and we are now actually going to go through and solve the problem. So we've been looking at these different word problems over the week, and we were just setting up the variables, setting up the equations, and then in previous cycles, we've actually figured out how to solve linear systems. Um, so there's 3 methods. There's graphing, substitution, elimination. Graphing is great. It's very visual and so forth. But if we do have an answer like 2.51 or some sort of decimal that's not exact, it's not easy to get an accurate answer with graphing. So we're going to use elimination or substitution today. And it's actually your choice, whichever one you want to use, okay? All right, so we're going to start with problem number 1. So speed, distance, time problem. And then we're going to go through right from scratch the steps of following, reading it, finding information, finding the variables, finding the equations, and actually going through and finding the answers. So like, for example, it says how many hours did he spend driving at 60 kilometers an hour and 30 kilometers an hour. So you're actually going to find how many hours that he actually spent in those different time periods, okay? All right, so let's get to it. Okay, so I've also added in these tables to help organize our work. Again, just keep in mind that you won't be given these normally, but yeah, so just like kind of get in the habit of just making them yourself when you're going through and solving problems. Okay, so again, the way you use these boxes can be different from the way your friend does it. So it's just a matter of just organizing all the information so that you can kind of build the equations. Okay, all right. So we have Terry driving a Mazda for 6 hours, and he traveled a total distance of 300 kilometers, and he averaged 60 kilometers an hour for the first part of his trip, but was forced to complete the trip at 30 kilometers an hour due to a winter storm. How many hours did he spend driving at 60 kilometers an hour and 30 kilometers an hour? Okay. All right. So you have to think about, so you know that they want you to find the time, and there's a couple different situations here. So you can call it the first part of his trip, right? Some of you might want to call it the 60 kilometers an hour part of the trip. So whatever works, okay? So you have the first part and the second part. That's what I'm going to write. I'm going to call them X and Y. And then what is it that I have to find? I have to find the time, right? That hours that he spent driving in these different parts of his trip. So this will be the time. Okay, so let's define those variables over here. So let X, okay, and then just keep in mind I didn't take off any marks with the checkpoints before with if you didn't write units, but make sure you're doing it now. So this is where I will kind of look carefully at it and take off marks this time. So let X equals, so the time taken first part of trip, I guess, okay? And make sure you're detailed. Again, I caught a few of you guys writing, just like nickels, quarters, but not telling me what about the nickels and quarters, or what about the first and second part, okay? So first part of the trip, second part of the trip, okay? Make sure just be more specific. Okay, time taken for the second part. And then don't forget your units, okay? Time has units of hours, so we need to specify that to get full marks, okay? All right, so from there, we need to build our equation. So time, do we know altogether how much time it took? So we're analyzing here. Yep, it took 6 hours, so we know we need to build an equation where 6 hours is the time, okay? We know some information about the speed, so we can jot that down to help us organize our thoughts. So we know the first part, he traveled at 60 kilometers an hour. The second part of his trip, he traveled 30. Okay, we don't worry about the total speed, okay, but we have another piece of information here, the distance. So we're going to write that in there. Distance. Okay, and then because you practiced already from the day before, hopefully you remember that you just take your, to find distance, you just take your speed and you multiply the time. You get 60x and 30y. Okay, and it does give us a total distance traveled, so there it is, 300. So now you can build your two equations. And then this is as far as we went the other day, okay? All right, but I just want to, now we do actually want to figure out what the x and y values are, what the actual times for the first and second part of the trip are. So we're just going to review the tools that we've picked up so far. So I created this note in the last cycle when we learned about elimination on how we are going to learn this year 3 different ways to solve linear systems. So the first one we did right at the beginning of the year is we graphed a couple lines. We found the point of intersection, and that was the solution, the x and y value. Then we did substitution in the next cycle. This is where we rearrange one of the equations so it's equal to one of the letters, like x equals or y equals, and then we plug it into the other equation. So here's a little scribble of one here. So here are two equations that are not equal to one of the letters. So I rearrange this one to equal to y, and then we threw it into here, okay, and then solved it. And then the last method, the most recent one, is the one where we line them all up, the x's and y's together, stack them up, make a decision which one you want to get rid of, and then make sure the number is the same, and then you add or subtract to get rid of the one of the letters, and then it's easy to solve, okay? So so again, I don't recommend graphing today because unless you're actually told, you know, find the solution to the system by graphing, I recommend just go do substitution or elimination because they can find the answer algebraically, and even if you have a fraction answer and so forth, you can find something nice and exact, where when you are graphing a line, if it's not perfectly going through the crosshairs, it's going to be a tricky answer to find when your graph, like you can't, you have to estimate between the squares and so forth. So again, I think like with this one here, I kind of showed you guys examples, like rearrange it, plug, or I think we did the graphing here, right? So we graphed it. Okay, here we rearranged it, plugged it in. Okay, so if you want to go back to this lesson and analyze it, be good. But elimination is one that you might want to use a lot today because a lot of the questions you actually line up the x's and y's nicely. So anyway, just quick review. So when you line them up, make sure the numbers are the same, and then decide, okay, if they're opposite signs, I'm going to add. If they have the same signs, then I'm going to subtract to get rid of the variable. Okay, so just it's up to you which method you want to use. Just try a substitution or elimination today. Okay, so we're analyzing the linear system that we've just built, okay, from our tables here, and I'm noticing that all the x's and y's are nicely lined up together. So, see, like the x's are together, the y's are together. So I'm thinking I'd like to use elimination, okay? But again, if you preferred substitution, go ahead and use it, and then see if you get the same answer in the end when I finish up here. Okay, so I'm just going to rewrite these down here. So here's my linear system. Okay, so there's my equation 1, and then my other equation. Okay, there it is. So what's happening here in this problem is that, we have all these scenarios, like it has to total up to 6 hours, it has to total up to a distance of 300 kilometers. And so we have a couple conditions that we have to follow, and your goal is to find there's one x and y value that works for both of these equations that will be the solution to this system, okay? So that's what you're trying to do here. So again, I'm going to use elimination just because my x's and y's are already nice and not lined up. So I'm analyzing here the x's, like they don't have the same number in front. The y's don't have the same number in front. So you just have to go, okay, I want to get rid of x, okay? So if you want to get rid of x, I need to multiply everybody in the first line by 60, okay, to make a match. But if you say you have something against y, you want to get rid of y first, so multiply everything by 30, and that will get rid of y. Okay, so I'm just going to use x. You guys doesn't okay. Lots of different ways to go about doing these questions. So if I'm going to get rid of x, I need to multiply this first one by 60. The second one's fine. So when I rewrite it, I'll just do it over here. Number one is going to become 60x plus 60y. Remember to multiply everybody by 60. Okay, everyone always forgets this last one here. Okay, the 6 here at the end. All right, so we're going to now rewrite the other one. So I'm going to call this one 1a now, okay, because it's a different version, I guess, of 1, but it's still the same as 1. It's just been multiplied up. All right, here is equation 2. It's still the same. So I'm still going to call it equation 2. Okay, so now that I have the x's, see how they have the same number, I'm now going to draw the line and make a decision here. Should I add them or should I subtract them to get rid of them? Okay, so see how they're both positive. So I need to use subtraction. And again, I always recommend that you put a circle around it like that so you don't think it's negative 60 for the bottom one here. Okay, so you know it's subtract everybody through here. All right, so if we do that, so 60 subtract 60x, it becomes 0, so you don't write it. So go to the next one, 60y subtract 30y is 30y. Bring the equal sign down, and then 360 subtract 300 is 60. All right, so a lot of people like elimination because it just quickly gets to one of the letters really quick. So, all right, so boot that over. Okay, so it was multiplied to 30, so I'm dividing it away now on the other side to solve it, and then we get 2, okay? All right, so I'm just gonna, yeah, so, and then sometimes some of you kind of stop and go, oh, okay, that's done, I must be done. So no, don't, remember your goal here is x and y, okay? So you found the y, so now you need to go and keep going, find the x. So again, so you know that x is equal, or sorry, y is equal to 2, okay? So now what you're gonna do is you're gonna place it back into one of these equations, okay? It doesn't matter which one, okay? I should just pick the simpler looking one. So I'm gonna use number 1, okay? And again, rule of thumb, I want you to always put it back in one of the original equations. For example, don't try to put it back in here, just in case you did make a mistake here, because yeah, because like the answer that you get when you go and plug it back in the wrong equation, it'll still come out okay. So then you're like, oh, I got the answer. Okay, so put it back in the original because something could have gone wrong in this step. All right, so here we go. I have this here, so I'm going to plug in the y. Here we go, and boot the 2 over. Okay, so it was added. Now we're doing the opposite. We're subtracting it on the other side, and then we get a 4. All right, so there is our equation. I'm not going to check, but you know how to check, and you can figure out if you did this right, okay, by checking and plugging it all back in. All right, so then what we did in the past is we always wrote the solution to the system is 4, 2. We're not going to do that anymore because we actually have a specific word problem that we're dealing with. We didn't know what x was, we didn't know what y was, but we actually do know what they are because we set a variable statement here. So x, in our case here, 4, represents the time taken in the first part of the trip. So it took, what was this guy's name? Terry. It took Terry 4 hours in his first part of the trip. And then the second part of his trip, he took 2 hours, okay? All right, so let's write that here. So therefore, Terry, because we wanted to know how many hours did he spend driving at 60 kilometers an hour and 30 kilometers an hour. Okay, so Terry spent 4 hours driving at 60 kilometers an hour and 2 hours driving at 30 kilometers an hour. And that would have been really slow, okay? All right, so, and that happens sometimes when, you know, the weather's bad. So, And if you wanted to word it where, oh, the first part of his trip took 4 hours, the second part took 2 hours, that's okay too for a final statement. Okay, so just make sure write the units with your answer, and you're not writing the solution to the system anymore, because we actually know what the x and y values are specifically now. Okay, before we didn't. There were just some x and y values. There were some numbers out there that we had to find the answers to, but we actually know what this is, an actual word problem that we're actually trying to find what the values are for these conditions. Like, okay, we spent 6 hours driving. We drove for 300 kilometers. So with those conditions, what are the answers that would work here? And it's 4 and 2. Okay. All right, so there's your first one. And so as we're going through, the checkpoint today will be, it'll be where you can pick from the checkpoints that you've already completed or started, I guess you can think of it, where you've built the equations and the variables, and then you're going to actually go through and solve it. Okay, so just watch the video, look at all the other ones anyway, but then from there you can make a decision on which one you want to solve. Like, oh, I like the speed questions, I'm going to do that one. Oh, I like the investment questions or the numbers and so forth. Okay, or you can do them all if you want. All right, so let's go on to the next one. Okay, so we have two numbers. They sum up to 6, and the sum of the larger number and 3 times the smaller number is 8. Okay, what two numbers are we looking at here? All right, so we have a couple numbers, so we need to jot those down, but remember one of them is larger, so that's important to specify that. Oops. Okay, and one smaller. Okay, so we're going to use the x and y. Again, it's your choice. And let's define these variables. So let x be the larger number. So again, make sure you're being specific. Some of you still wrote larger, smaller last time, so on your checkpoints. So just make sure smaller, larger, what? Number. All right, and we don't have units for just trying to find some numbers, so you don't need to write the units in. All right, so the first sentence here says the sum of the two numbers is like equal sign, the sum, okay, think of it as like, adding them up, is 6. So we know we can add these two numbers up and get a total of 6. All right, the sum, so again, we're adding the larger number, which we decided was x, and 3 times the smaller number. So 3 times the smaller number is 8. Okay, so let's go through and translate those out. So we have the sum of so we're adding up the larger number and 3 times the smaller number. And so they're saying that the sum of all of that is 8. All right, so here are two new equations to represent this problem. Okay, so if we take the two numbers and add them, we should get 6. If we take the larger, add it to the 3 times the smaller, we should get 8. So those are the conditions that we have to abide by. Okay, all right, so if we're going to go through, I know last time I did the elimination method. I'm going to show you how to do the substitution method here for anyone that just wants to see that method again, okay, just as a review. And again, but if you prefer to do the elimination method, go ahead and do that and see if it matches up with the answer that I get, okay? All right, so substitution means, so that method here, we have to rearrange one of these equations to equal to one of the letters, and then we're going to sub it into the other one, okay? So I'm going to rearrange this first one here, and so I'll just move it over here. So I'm going to rearrange it for, I don't know, the letter X, okay? So I'm going to move this Y over here. So I end up with 6 subtract Y, okay? All right, so now that I've solved for X, I'm going to move and put it into this equation here, okay? So like this was equation 1, that's equation 2, so I'm going to put 1 into 2, okay? So here, so if I change it to a different color so you see where I sub it in. So I'm going to sub in this where the X is right now, okay? So I take out the X, replace it with 6 subtract Y in brackets plus 3Y equals 8, like that. Okay, all right, nothing's, I can just drop these brackets here. Okay, there's no number on the outside of the bracket, so I could just drop them. All right, there's no negative sign or anything, so. All right, so from there, we know these are like terms, so let's add those together. So we have a -1 added to 3. The positives will win by 2. All right, and then, so once you sub it in, this is the substitution method. Once you sub it in, it eliminates one of the variables so that you only have the other one left, so you can solve for it. Okay, so move that. Okay, so see how it was +6. So when we move it over here, it should be subtracted away. And then move the 2. And then get to 1. All right, so again, if you prefer the elimination method, that's fine. It would still come out to the same answers. All right, and yeah, some people might argue it's a lot less writing. True, true. So, but always have lots of different ways to do things, okay? It's an advantage. So, all right, so like I said before, make sure pick one of the original equations. Don't like say pick this one where you rearranged it. Pick one of the original ones, because if you made an error here, we can pick it up, okay, when we check it. So, so go back to here. I'm picking the simpler one. I know that y is equal to 1. So I'm going to sub it into here. And there it is. And then we're just going to solve for x. Okay, so here is our new point. 5 and 1. Okay, all right, so again, we're going to not say the solution to the system. We're actually going to pay attention to what x and y were. So if it helps, you can even make a little note like, oh yeah, x was the larger number, right? Y was the smaller number. Okay, because we actually know what x and y are. We're not just going to call them x and y anymore. Okay, so now let's make our therefore statement specific to this problem. Okay, so what was the question that they asked? What are the two numbers Cal is thinking about? Okay, so therefore, numbers are 5 and 1. Right, let's move on to the next one. So we covered speed question, number question, the other type that we looked at, a money type question. So here we go. So we have a coffee machine, has $1.25 in quarters and nickels in it. There are 9 coins. How many are there of each type? Okay, so we got some quarters, some nickels. Okay, and then, yeah, feel free to use what letters that you want here. Okay, and define the variables. So let x be the number of quarters, okay? So and y be the number of nickels. And we don't need any units as well. Okay, so just make sure to specify what about the nickels and quarters. A lot of you just wrote x is quarters, y is nickels. So that's just too vague to get full marks, okay? All right, but we don't need any units because we are looking at just a quantity of things here. So, all right, so we know that the total cash amount value is $1.25. But we do know that there's a total of 9 nickels, so we can at least complete this statement here and make that equation. So that's the number of coins. All right, so now this is the amount, the value, I guess, of what's inside this piggy, or no, not a piggy bank, coffee machine. So quarters, again, you need to multiply by 0.25. Okay, x, and then the nickels, 0.05, y, for a grand total of $1.25. Okay, so here are your two equations. All right, and that's as far as we went last time, but we're going to keep going. We are now going to find literally how many quarters and how many nickels are in this coffee machine. All right, so I used substitution last time. You can use it again if you want. I'm going to go back to elimination. Okay, so there's my equation 1. And here's equation 2. Okay, so again, you line up the letters, line up the numbers, the constants, the equal sign, and then you take a look and go, okay, well, I want to get rid of one of the letters, but right now, like there's a 1x here and a 0.25x. We have a 1y here and a 0.05 y here. So we don't have the same coefficients in front of the letters, so we have to make a decision here and multiply. So like right here, the first one doesn't have the same number. So what I'm going to do here is I'm going to say I want to take out the y this time, okay? So I'm going to multiply this whole line here by 0.05 so that I can get 0.05y. So let's do that here. When I do that, I will get 0.05x, 0.05y, and don't forget to multiply this one as well. For some reason, people always forget, so. Okay, and now that's like the new version of number 1, so we'll call it 1a or 1b, and then the other one is still the same. Equation 2 is still the same, so 0.25, sorry, and then 0.05 and $1.25. Okay, so that's still equation 2. All right, so now we have the y's look the same, so now we can use the elimination method here. And you have to decide, all right, do I add or do I subtract, okay? And if you're taking a look here, they're both positives, so you're going to subtract to get rid of that variable y, okay? And I'm going to put it in a circle like that. All right, so what you're doing from here is you're going to go through and subtract everybody. So that first one, scroll up a bit here. So that first one here, so you have like 5 cents takes on 25 cents. 25 cents is going to win, right? So they're negative, so it's this minus that. So you're going to, the negatives will win by how many? By 20 cents, okay? All right, 0.05 subtract, 0.05, gone. Equal sign comes down. And so now, same thing here, 0.45 comes in and tries to take out 125. So you go 0.45, subtract 125, nope, so the negatives will win, 0.8, okay? Otherwise, you're just subtracting them and you get this number here. All right, and then, you know, I know they're all decimals, don't panic, just keep going with it. And so you have a negative 0.2 here, you need to divide it away, so that leaves you x. And then you divide by 0.2 here. So that'll move the 0.2 off the x, and then you can solve for x here. Okay, so then that comes out to 4. Okay, so negative, negative makes positive. All right, and then as you're going along, I don't know if you got some negative for some reason, you just kind of do a little check and go, well, wait, I have to know how many coins there are, so I can't have a negative number, so go back and double check your work, okay? All right, so then now you have x is equal to 4. Our goal is, remember, to find x and y, so we have to go find y. I'm looking at both of these, doesn't matter which one of these you use, I'm just going to use a simpler one. Okay, and we'll plug it into here. This time we're going to plug it in the x. Okay, we're going to move the 4, and the y is by itself. The 4 was positive, now it's subtracting over here. So now y is 5. Okay, so that leaves us with an answer of 4, 5. What does that mean? In this word problem, it's about the coins, right? So how many are there of each type of coin in this coffee machine? So again, pay attention, go back to your variable statement and pay attention to which one was x, which one was y. Okay, so this is the number of quarters. This one's the number of nickels, okay? All right, so now when you do your therefore statement, so again, I recommend that you kind of label the final point. so you know what variable represented what variable, okay, or what number. So just because as we go through more and more word problems, you need to be, figuring out what does this number mean and what does that number mean, okay? All right, so therefore there are 4 quarters and 5 nickels, okay, in the coffee machine. So again, it's important that you know which one's which machine, because you don't want to do all this great work and then you get these backwards and you say, oh, there's 5 quarters and 4 nickels, right? You don't want to like do all of this work and get that one little part wrong because you weren't paying attention to which way, because again, you know that this was X, that was Y. So these were the quarters and these were the nickels, okay? So just make sure you know which one's which. All right, so hopefully that wasn't too bad. Getting a kind of good review in for elimination and substitution, and also getting really strong at these word problems now. All right, next one, tickets. So again, I think it seemed like you guys had a good, easy time with these money ones, so that's good. So we have some adult tickets, and we have some student tickets. Okay, so we'll call them X and Y. Okay, and again, this work here, I might analyze it to see if you made a mistake, if something goes disastrous here, but I'm not going to mark this part, okay? So you can kind of write what you want there, but then this is where I need to see it written properly. So X is what about the adults, okay? It's the number of adult tickets. Okay, or it could be the number of adults that attended this party. All right, and Y is the number of student tickets. Okay, because they want to know how many adults were in the audience in this case here, okay? But we're going to find both anyway, so that we can kind of build our equations and get to our answer. So again, one adult ticket costs $6. So like, and the other one's 4. So you need to build the $6 and the $4 like that. Or you can write, 6x, 4x. That's fine too. For y, sorry, this should be y. And there were 750 people that did attend. And the total amount of money that they made with $6 per ticket, $4 per ticket, was $3,890. Okay, so in the end, we need to know how many adults attended this party or play. Sorry. Okay, so there are the 2 equations. Okay, and again, up to you. You can use substitution or elimination. I like elimination. It's a little less writing, so let's get there. But again, always know how to do things lots of different ways, because sometimes substitution is convenient as well. Okay, so there are the 2. I want to eliminate one of the variables. Just take a pick. Okay, let's get rid of X this time. Sometimes one's like definitely the one that you have to get rid of. It's easy to see. Sometimes you have a choice like that, okay? All right, I'm going to multiply the first one by 6. So everyone gets hit with 6, multiply by 6. And don't forget the last one here as well. All right, and then the other one stays the same. So again, we're going to call this one 1A now. Slightly different, but still the same as the original. We're going to keep this one the same and make a decision here. What are we going to do? Well, we want to get rid of the X, right? So we're going to subtract. Okay, so when I take 6 and subtract by 6, it's gone. Okay, so 6y subtract 4y is 2y. Bring the equal sign down. 4,500 subtract 3,890 is 610. All right, put the 2 over. But when you boot it over, it becomes divide. And then you have 305. Okay, so y equals 305. All right, so let's now go back to one of the original equations. I'm taking the simpler one and we're plugging it in here. Okay, boot that over. And get to an answer of 445. Okay, so our x and y values here. Okay, so again, make sure write them in the right order. So that's the x, this is the y. And then you go back to the original variable statement up here, and x was the adult, right? These were the adults. Okay, and these were the students. Okay, all right, so just kind of make that match up and then write your therefore statement. So therefore, what did they want? Well, so in this case here, they just wanted to know how many adults were in the audience, and then that's all you can write. If you went and wrote how many students as well, that's fine. You are just stating everything here, so that's fine. But want to write a little bit less, you could just write, therefore, there were 445 adults in the audience. Okay. All right, so hopefully you're feeling pretty confident you can tackle any kind of question here. Okay, we'll move on to investments. Okay, and keep going. But if you're at the point where, is that the last one? No, there's 3 more. I'll try to go through them quickly. If you're feeling you're pretty confident with these, you know how to build these equations, yeah, you're ready for the checkpoint. You don't need to watch all 7 of these. But again, if there's one that you really like, or actually, you know what? The age one is important. There's a slight little trick to it at the end. So definitely, at least skip to the age one and watch that one, okay? All right, so let's go to investments here. So again, we have a 14% and we have a 12% account. So hopefully you feel comfortable about what investments mean now, okay? All right, so we have an x and y to assign here. So x is going to be, again, we are taking some money and putting it into these accounts, right? So amount invested. Okay, invested means to place in to the bank or somewhere, and then it makes money for you. Okay, so it's an investment. Amount invested at 14%. Okay, and we're going to put $ because it's amount of money. All right, and then amount invested in the 12%. Invested at 12%. Again, money to get full marks. All right, so what do we know? Well, we know that there was 20,000 altogether. We were splitting it into pieces in order to invest. And then we also know that when we left our money in there, we invested the money and we came back after, it says per annum, after a year, we found that we made $2,660. Okay, so what you're going to do here is you're going to multiply the percent, but remember as a decimals, 0.14 times the x, and then 12% as a decimal, 0.12y, and you add it up to the 2,660. Okay, so here are the 2 equations. Yeah, go through, pick a method, substitution or elimination, and solve for x and y. Solve the system. So that's what you're doing now, but you're writing a specific therefore statement now. Okay, so I'm just gonna save some time here and just kind of start from here. There's equation 1, there's equation 2. I'm going to get rid of y this time. So what I need to do is I need to multiply this whole line by 0.12. Okay, so when I do that, Actually, I'll do it over here. And that all equals, I'm going to multiply the 20,000 as well, 2,400. Okay, and there is now my 1a. Okay, all right, I'm just going to write this one in red as well. So this is equation 2. We didn't change it at all. We're just rewriting it underneath. There's equation 2. All right, and then make a decision. Are we going to add or subtract to get rid of the y? We are going to subtract. Okay, so when I subtract these two though, you're going to end up with a negative 0.02, and the y disappears, the equal sign comes down, and you end up with a negative 260 on this line there. And then you're going to take this and boot it over. Okay, so remember that negative comes with it because we're just dividing it away. And then you end up with negative and negative makes a positive. And you end up with, okay, the 13,000. Okay, so you know 13,000 is going into the one account. So if it's X, into the 14% account. And then you could just quickly subtract, right, to find the other one. But this is what you've always been doing, so you know that X is 13,000. I want you to show your work and how you come up with the other one. Well, you know that they add up to 20,000, so if I plug it in here, all I'm doing is subtracting it from the 20,000 to figure out what the rest of the money should be. Okay, and then you will get, okay, so then 20 minus 13, or $7,000. All right, so here is our final answer. Okay, but again, you need to know which one's which. Okay, if you get it backwards, you don't get full marks. So remember, this is your X, that's your Y. That's how we always write the points. What did X represent? Well, X represented the 14%. The Y represented the 12%. So therefore, okay, again, how much money was invested at each rate. So therefore, the 13,000 was invested at 14%, and 7,000 was invested at 12%. Okay, all right, so just, yeah, be specific when you write your therefore statement. I don't want to see the answer is 13,000 and 7,000, okay? I need you to be specific. Even if you like wrote, oh, the answers are they placed 13,000 in one count and 7,000 in the other. That's still too vague. I need to know which account it actually went into, okay? All right, let's move on to the next one. Okay, so food mix. All right, so we have our almonds, and oh, I know I said that I'm gonna get you to take some of the checkpoints that you already completed, but if one of your checkpoints is actually on this list, I'm gonna actually have to change the numbers. So anyway, it'll be similar to your checkpoints. I think this one was on your checkpoint, or yeah, so anyway, I can't remember. So here we go. We have some almonds and we have some raisins, both chocolate covered. Okay, so let X be, okay, what about the raisins and almonds? We want to, like, we're trying to buy a mass of them, okay? I know we're trying to buy a certain amount, but it's based on mass. So the mass of almonds, and what are the units? Kilograms, okay? I think last time it was pounds, or some of the problems that we did. And then the mass of raisins, Okay, and all right, so okay, so we know this is like the mass. So do we know the total mass? 10 kilograms, okay? And then we have the cost. Okay, so almonds, well, they cost $30 per kilogram. So we're going to multiply that by 30x, and then the raisins are $10 per kilogram, so 10y. All together, what did we do here? It cost $150. Okay, so it's already been multiplied. We found the total here. All right, so here are there two equations. Our goal is to actually go and find now what mass of each of those almonds and raisins that we bought to make this mixture. That's 10 kilograms, and it cost us $150. So, all right, I'm going to carry on with the elimination method, okay? And it's up to you what method you want to use, but it should come out to the same answer still. Okay, I'm going to start from here as well. I'm looking at this and going, all right, I can get rid of x, or I can get rid of y. I don't know, let's get rid of x this time. It doesn't matter, it'll come out the same. So in this case here, we have 30x plus 30y. So again, I'm multiplying 30 here, and 30 here. So then I get 300, and that's my new equation 1. We'll call it equation 1a, and then here, this is equation 2. All right, and then I'm going to subtract. So again, if they had opposite signs, you would add, okay? So just don't get too comfortable and assume it's always going to be subtract. Okay, subtract. Okay, so these are gone. Then we have the y's can be subtracted and leave a 20y behind. And then 300 subtract 150. Then you get still 150 left. Okay, so we're going to take the 20 and boot it over here. So the 150 divided by the 20 makes 7.5. Okay, all right. And yeah. Okay, and then now we're going to go find our x value. And it's okay that I know I've gone to a decimal here. So, we can keep it as 15/2. Okay, but it's okay to work in decimals and then come back out. So, yeah, so we'll just keep it as 7.5 for now. Plug it in here so we can figure out what the value is here, and we will divide or subtract the 7.5 across here, and we get 2.5. Okay, so 2.5. All right, so again, if we want to keep it as so we have the x first, so 2.5 and 7.5, like that. Okay, or we can change it to 2.5 and 7.5, and we could go to improper fraction as well. Okay, 5/2, 15/2. Okay. All right. So in the end, we're making our therefore statement. Okay. So again, this was the x, and that's the y, but those were the almonds, those were the raisins. Okay. So just make sure when you're writing a therefore statement that it matches the right number. Okay. So therefore, I wanted to know how much of each is in the mixture. Okay, so we have, therefore we have, or whoever has, so 5.2. Okay, so again, if you're looking at kilograms of almonds and 15/2 kilograms of raisins. Okay, and I know some of you might argue, well, no one ever talks like that. So, if you left it as 2.5 kilograms, 7.5 kilograms. It's fine, okay? All right, but yeah, just try to keep in fractions, reduce fraction form for academics so that, you can keep practicing your fractions and so forth. All right, next one. All right, the age. I think this is the last one. Yes, okay. So, so today, if you're wanting to practice as well, I gave you all the questions already from the last few days. You're actually just going to go through and solve them. So you would have noticed that the answers are at the bottom of those pages. So that's why you're actually going to go through and you can check your answers, but I'll have full solutions that you can look at as well. Okay, so we have Andy and Ashley. Okay, so Andy and Ashley, we'll call it X and Y. So what is it? We're talking about their ages, blah, 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 this stuff, and we want to know how old will Andy be in 10 years. Okay, so for now, we're just going to go with, and X can be Andy's age now, okay? Andy's current age. Okay, and years. And then we have Y, Ashley's age, again, the current age, okay? We'll deal with the in 10 years age in a second. Okay, so we're going to go through and translate these. All right, so twice Andy's age, 2 times Andy's age, increased by 3 times, okay, Ashley's age is 93. All right, so let's just create that. So we have twice Andy's age, 3 times Ashley's age, added together makes 93. Okay. All right, so we also have the next one, 5 times Andy's age, decreased by 4 times Ashley's age is 37. So we have Andy's age, 5 times Andy's age, decreased by, so subtract 4 times Ashley's age is 37. Okay, so we built our 2 equations. We have our variables. This is their current age. So we're going to go through and solve it, but then in the end, we need to figure out 10 years from now. So like in 10 years, what will Andy's age be? So we'll deal with that part in a sec. So for now, let's just build our 2 equations here. All right. So equation 1, equation 2. So again, whatever method you want to use, I'm going to just go with the elimination again, just because like everything's kind of lined up already. The x's, the y's, the equal sign, and the constants here. Okay, so this one's a little bit more complex than the ones that we have been dealing with above because I'm looking at both the number letters x and the y's, and they're not the same, but I can't simply just multiply one of the letters by, like one of the equations by a number and get this to work. Like for example, 2 right now, I can't multiply 2 by anything to get to 5, right? This is decimal, right? But 3 I can't multiply to anything to get to 4. So we're going to have to multiply both of these equations up to the same number in order to eliminate them. So it's up to you what you want to do here. So I have 2 and 5 for x. So if I were to multiply them up, they both have 10 in common. The 3 and 4, if I multiply them up, they both have 12 in common. So you just have to make a decision what you want to do here, okay? But it will still come out to the same. So I'm just going to get rid of the x's here. So I want both the x's to come out to being the same number. So I'm going to multiply them both up so they'll become multiplied to 10. So if I were to do that with number 1, I have to multiply this one by 5 to make this 10, but then everybody else gets multiplied by 5. In this case, the second one here, for me to get 5 to become 10, I have to multiply by 2. But then everybody else in the equation gets multiplied by 2. So let's rewrite these. So for number 1, multiply by 5, you get that. Multiply this by 5, you get that. And then 93 times 5 is 465. Okay. And the next one, so multiply that by 2, multiply this one by 2, and then multiply 37 by 2, and you get 74. All right, so now we are ready to do something with this. Okay, so just kind of analyze that and go, okay, well, I'm trying to get rid of x. Right now they're both positive 10, positive 10. So the way to get rid of the same signs like that, I subtract it. Okay, so when we do that, now be careful here. The reason why I circle this out here is you're going to go 10, subtract 10, gone. Now go to here, 15, subtract negative 8. So it's like 15, subtract negative 8. So be careful there, okay? So hopefully you see that that's 15 plus 8 makes positive 23. Okay, so I know you're not really used to kind of subtracting and adding integers up and down like this. So if you have to just write it over here like, oh, 15 subtract 8. Okay, that's the same as 20 or 15 plus 8, which makes 23y. Okay, all right, bring the equal sign down. 465 subtract 74. Okay, so that's why I kind of keep bouncing to the operation that you put in the circle to remind yourself that's what you should be doing with all of these numbers. Don't start adding all of a sudden, okay? All right, so we get to 391. And now we're going to solve for y. We're going to move the 23 over. So right now it's multiplied, so we're going to divide it away. And then we get to 17. Okay? All right, so there is y. And then now we have to solve for x. Okay, so again, they both look about the same amount of work. Doesn't matter. I guess I'll use the second one. Okay, so there it is. So I'm going to plug it into where the y is. 5x 4 times the 17 equals 7. All right, put the 68. Okay, so subtract there, so now you can add it over. Comes up to 105. Oops, and we're going to boot the 5 over. Okay, we divide it over on that side, and then we end up with 21. All right, so a little bit more work, but that's okay. We got to there. So in the end, we ended up with, okay, so again, pay attention to which one's which. X is 21, so you write that one first. Y 17. Okay, and what is X and Y? Well, it's Andy and Ashley's current age. Okay, so this is Andy, and this is Ashley. Okay, but remember, the problem said, how old will Andy be 10 years from now? So we know Andy is 21 right now. So 10 years from now, we need to add 10, okay? So he's going to be 31 10 years from now. So make a therefore statement. How old will Andy be in 10 years? Okay, so Andy will be it crashed. Oh, okay. In 10 years. All right, Andy will be 31 years old in 10 years. Okay, so now that you should be an expert. I think you are. Okay, I've marked some of the checkpoints already, and it was looking good. So now going back and refreshing on elimination and substitution, that's all you have to do here. It's good practice. This is why we're cycling the course. So you see things over and over and over again until you're awesome at them. So hopefully you are now awesome at substitution and elimination, that you can go through, find these, and then the new thing, write your statement as a statement that matches the problem, okay? Don't write solution to the system anymore when it's a word problem. Write something about Andy, something about Ashley, something about the coins, and so forth, okay? All right, go and try your checkpoint. Oh no, we'll practice a little bit if you need to, and then write your checkpoint.